Okay, so number 31 says many couples want to have both a boy and a girl. If they decide to continue to have children until they have one child of each sex, what would the average family size be? Assume that boys and girls are equally likely. Okay. So step 1 is, what are we simulating? Having children, right? So we are simulating having children until there is one girl and one boy. It's a risky endeavor. I have friends who kept trying. They have 6 girls. They finally were like, nope.
They wanted a boy?
They wanted a boy. They kept trying. They got 6 girls. 2 is enough, let me tell you.
After you say you want a girl, then you get a boy.
Right. I know people that have tried for a girl and they have 6 boys. Okay, so how are we going to divide up our numbers if it's equally likely? Are we going to use 0 to 99 or 0 to 9? 0 to 9 is easier. So we're going to let 0 to 4. Do you want that to be a boy or a girl? It doesn't really matter. Okay. And then 5 to 9, be a boy. Then what? It doesn't matter whether you use a random digit table or the calculator. Calculator can be easier, faster sometimes, right? So we're going to use a random digit table, 1 digit at a time. This is what a lot of your homework was missing. Explaining what you're doing. And then some of you just said use a random digit table, 1 digit at a time. Okay, so now what? What are we doing? We're recording how many children? Until we have a boy and a girl.
So no matter how many trials we do?
10 is the standard.
35.
Okay. So that's step 1, 2, and 3. What are we simulating? Okay. How are we going to divide up our numbers? How are we going to use the random digit table or the calculator? Right? Not only I'm using that this many digits at a time, but also what consists of one trial, right? You need to explain how one trial is going to be run. And I still don't have a random digit table saved in my files here. Let me see. Hold on. We're a little further down on this table now. I'm just going to crop some of it so it doesn't take as much space. Okay, so we're going to start on line 120 just because. You're not expected to copy your random digits into your homework, but you are expected to write down what you get for each trial. How many kids? That's what we're recording, right? So a lot of you had answers, but you didn't write down any of the numbers you got for your trial. Yeah.
Is it average amount of kids until one boy girl? Out of the amount of family, including the mom and the dad?
It says, what would the average family size be? So I guess technically that would include mom and dad, but either way, how many children? So, okay. So we're going to start on this line here. 3, girl. 5, boy. End of the trial. Trial 1 is 2 kids, right? 4, 7, 2 kids again. 6, 5, boy, 5, boy. Woo! 1, 2, 3, 4, 5, and 6.
What does the step state what the response variable is?
Oh, I forgot that one, right? That's what are we going to calculate at the end? So our response variable is the average family size. So we'll include mom and dad. Okay. Either way, just to say whether or not you do. It doesn't, I don't think it really matters whether.
Number of kids, is that okay?
That's fine. If you say average number of kids, then that's okay, right? There's a lot of leeway as long as you explain yourself well, right? Okay, the next one, 3 girl, 9 boy, 2. The next one, 4 girl, 2 girl, 1 girl, 6 boy, 4 kids. 5 boy, 8 boy, 5 boy, 0 girl, 4 kids again. Girl, 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 boy. 4 kids again. Boy, girl. That's 2. Boy, girl. 2 again. 1, 2, 3, 4, 5, 6, 7, 8, 9. One more. 3, 5. Boy, girl. 2 again. Okay. Now I can add those all up and divide by 10. What do we know about if I'm adding 2 to all of these data values? How's it going to change my mean? It'll go up by 2, right? So if I average the number of kids and then say, oh, I'm supposed to include the parents, that just adds 2 to my mean, right? We did that in chapter 6. If I'm shifting all the points over 2, my mean just increases by 2. So I can add up how many there are. That's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Right? Is that up to 30? Sure. Over 10 is 3. So on average, 3 kids, which means a family size of 5. Okay. So that's analyzing our response variable. Just calculating the average, that's just one of the 7 steps. It's not like a huge production, but you have to include that. You can't just state what your answer is, right? You need to show these numbers and then show your calculation. And then lastly, based on our simulation, I would expect an average family size of 5 if the parents are trying until they have one of each. All right, so dice game. You're playing a children's game in which the number of spaces you get to move is determined by rolling of a die. You must land exactly on the final space in order to win. Right? So if you're 2 spaces away from the final space and you roll a 3, do you win?
No.
No. If you roll a 10, do you win? Not a 10, a 6. No. It's not passing that final space. It's that rule where you have to land on the exact space, and it's so frustrating, right? Because it's so much harder to get that one number than get past that number, right? Probability changes. So what is we simulating? Playing a board game. Some kind of children's board game. If I am 10 spaces away, how many turns might it take for you to win? So you have to equal 10 exactly. If you roll and now your sum is 11, you have to say, my turn is over, you go again, and then I'll roll again, right? You have to stop and think about what you're actually simulating, right? And I worry that some of these experiences are things that you don't have anymore. Like, have you played board games?
Not with my family.
Ever?
Well, not in a while. My family doesn't like to play board games.
I mean, I haven't played board games with my kids in a while either, but I mean, when they were little, we played Candyland and Chutes and Ladders, and I try to avoid Monopoly at all costs because it takes forever. And the Game of Life. Okay, so it's just like cards. When we do problems about cards and probability, so many people don't play cards anymore, so it makes that probability hard. That's good.
Scum. You should play Scum. Is that what it was last year?
We played cribbage last year.
Scum was the first card game that popped in my head. I played Scum. It was cribbage.
Okay, so we are rolling a die. 1 through 6. So if we're using a random digit table, we're going to have to ignore some numbers, right? There's no way to make 6 numbers fit into 10 or even 100 evenly, right? So we might as well just say, use the numbers 1 through 6. We're going to ignore 0 and 7, 8, and 9. You can just ignore them, okay? So if we're using a random digit table, that's how we're going to do that. So we're going to use 1 through 6 to be the roll of the die. We're going to ignore 0, 7, 8, and 9. Yes?
We're ignoring 0 because there's not a 0 on the dice.
Correct. And there's not a 7, and there's not an 8, and there's not a 9. Right? So we have to ignore those. Now, or we can use a calculator in which we're just going to use the numbers 1 through 6. That's the nice thing about the calculator. We don't have to worry about needing to ignore stuff. We can say, we're just going to use 1 through 6. So we'll use a calculator on this one. But if this was a problem on the AP exam and you had random digits, that's what you would have to say. Ignore these things. Okay? So we're going to use rand int 1, 6 until the total spaces moved is exactly 10.
You don't have to put the numbers in front?
That's part of the trial, right? What I'm trying to figure out is how many numbers is it going to take me to get exactly 10. So I can ask it for 10 numbers, but that may not be enough. So I'm really just going to try to do one at a time, one roll at a time. Okay. Having it generate like 10, 12, you could have it generate 25, 30 numbers, put it in a list, and then use that list as your random digits. That might be faster than enter, enter, enter. It's up to you. Okay. So exactly 10 spaces. If it goes over, we ignore that number and we count it as a trial or as a roll. Right? Think about it. You're 2 spaces away. You roll a 3. Your friend's not going to let you win. You lose your turn. It still took another turn. You didn't get to move your guy. And your friend gets to go now. Right? Usually your friend implements this rule when they're way far behind you and you're almost at the end. Right? And they know that if you have to land exactly on 2, they've got time to catch up. Right? But if it's in the rules from the beginning, you kind of have no argument. Okay, so your friend's not going to let you win and the game be over. You have to sit there while they take their turn, and then you have to take another turn. You don't get to move your guy even 2 spaces, right?
How come we don't use the dice roll simulator on the calculator?
Because I don't know that it is truly random. And so on the AP exam, they're not assuming that you're going to use your calculator's dice roll simulator. They want you to use the random digits, right? Or the random digit table. And that's not really simulating it that much. You're still saying, oh, look, I'm rolling a die. It may be on a computer, but I'm rolling a die. Not like we want numbers to represent what we're trying to simulate. Okay, so let me grab my calculator. And let's do this. I'm trying not to hold it. So you either have to hold the calculator or I have to hold. I either have to hold the calculator up or I have to hold the iPad up. So there's no winning. Okay, so math over to probability down to randint. I want numbers from 1 to 6. I'm going to go one at a time. Okay. Okay, so I need it to add to 10. Exactly. 5, 7. I'm over. That's roll 3. Keep going.
Wait, so can it be any, like, you can did it like 4 rolls, or like say 5 rolls of 2, does that count?
Yeah, 5 rolls of 2
Oh,
counts.
okay.
Because, right, remember, you're playing this game. You roll a 2, you move your guy 2. You roll 2, you move 2. You roll 2, you move 2. 5 times, you made it, right?
So you don't end the trial when it goes over?
No. Your friend, ending the trial means you won the game. You don't get to win because you went over. You have to land exactly on the 10th spot. Your friend's like, no, you didn't win. You didn't get 10 exactly. Right? That's what your friend is saying to you, or your little sister.
No.
You didn't get 10 exactly. You don't get to win. The game's not over. I can still win.
So within that trial, like after you go over 10, you still start over at 0 after
No, no, I'm still at 7.
Oh,
I'm still at 7.
Oh.
Remember, I'm like on this little path here. I got 10 little spots.
Oh, I did it.
Okay, here's my little guy. I have to land here. Here's the promised land. Yay, I win. Right, so my little guy's here. I moved 5. 1, 2, 3, 4, 5. Then I rolled a 2. So I get to move my guy 2. 1, 2. So there's 5. There's 2. I rolled a 4. I have too many spaces here. Right? I'm 3 away. So actually this is my promised land right here. I rolled a 4. That's more than the 3 spaces. So I have to stay where I'm at.
you don't count the 4.
Yes, I count that as a roll, a turn, right? I took my 3rd turn. I don't win because I didn't land exactly on that spot. I rolled again. I got a 5. That's over again. I don't win. I didn't land exactly on that spot. Now that's 4 rolls, 4 turns. Roll again.
Oh,
I didn't do it.
It didn't do it. Another 5. Still didn't win. That's my 5th turn. There's 3.
6.
1, 2, 3. Yay, I win. Right? And it took 1, 2, 3, 4, 5, 6 rolls to win that game. So what I'm writing down for my trial
is that the response variable?
is 6. That's the trial. 6 is the trial. My response variable is the average number of rolls it took to win. Right? I forgot to write that down again.
We have to do this 10 times?
Yes. Okay, does that make sense with the picture now? Does that help?
Is this the only way to do it, or could you like switch it? Because what I was thinking was like there's 2 dice, so
But this game only has 1 dice.
does it say?
Yes.
Yeah, it just says die.
It says rolling of a die. Yeah, so 1 space, 1 die. Okay, yeah.
So we write how many times it took us to get to the 10.
Yes. How many times did it take you to get to the 10th spot? That total of 10 without going over.
How many trials did it ask for?
If it doesn't say, we do 10.
Okay.
Okay. Okay. Better? We understand better? Okay. So let's do one more. Okay. I'm just going to clear. Well, or not. So I got 5.
5.
10.
2.
I won. 2. This one only took me 2 because I got 10 in 2 rolls. Okay. Now let's do it again. This is our third time. 1, 3, 9. So now I have to keep rolling until I get what?
1.
A 1, right? So this is my third attempt. Oh, I got lucky. 4, right? I got 1 on my 4th try. That added to 10, so that trial was 4. Okay.
Mine doesn't go up to 9, it just goes up to 7.
That's because you put it in the calculator.
I'm talking about our sum. 1 plus 2 is 3, plus 6 is 9. Now I need to get a 1 so I can get my total of 10 spaces moved. So 5 over 8 over 10. That took 5 rolls. Right? You guys see it? And then we go again. 5 over 7 over, because that's 11, so that doesn't count. 8, 9, 10. 6 rolls. Okay. How many more do I need? 5 more? Okay, let's just do 5 for the sake of time. Okay, so we'll do 5. So we'll analyze our response variable, which means finding my average number of rolls it took. So that's 10, 17, 23, right? 23 over 5, which is 4.6. So, based on my simulation,
You have a lot lower numbers than I did.
yeah, and that's okay, right? Because we're all generating different numbers with our calculator.
I just hit 22.
22. Your sister already won at that point. Based on my simulation, I would expect it to take an average of 4.6 rolls to get exactly